In 1997, IBM Deep Blue defeated the human world champion in chess. This was before I was even born. Chess is a static game with a limited number of possible moves. And now, over 20 years later, it is possible to tackle more challenging problems. For example, letting robots play soccer autonomously. Soccer is a well-known game where there is a dynamic environment with endless possibilities, safety considerations, and teamwork. These factors make it much more complicated to develop an artificial intelligence for soccer than the relatively simple game of chess. It is exactly this challenge that we, RoboTeam Twente, have taken on for the past 5 years. Welcome everyone to the reveal presentation of RoboTeam Twente. I am Cassandra and this is Flores, and we would like to thank you all for coming to see what we've been working on for the past year. We are the 5th generation of RoboTeam Twente, and each year we aim to innovate and inspire in the field of robotics and artificial intelligence.
We are able to persevere and improve thanks to all the hard work of our previous team members, who have laid out a great foundation for us to improve upon. Furthermore, we would like to especially thank all our partners for supporting us and giving us the opportunity to work on this amazing challenge. This year has been unlike any other year. We've moved offices twice and had to work from home for a couple of months. Even in these circumstances, our members have pressed on and continued to work hard. The competition we usually compete in, the RoboCup, has, like many other events, been moved to an online environment. This means we are still able to test our software, as the matches will happen in a simulator. The disadvantage of a simulator is you don't need the hardware we've been developing this year. Fortunately, the virtual RoboCup has included 4 physical challenges, focused on passing, dribbling and scoring. All of these challenges can be performed within the comfort of our new workspace and showcases the hard work of our electronics and mechanics team.
To bring everything together and play a full match, we are very excited to have organized a small tournament in August. Here we will demonstrate the fusion of hardware and software in a full 11 versus 11 soccer match. And now, the part you've all been waiting for, the reveal of a brand new generation of robots.
In the design presentation, you could see all the technical details of the implementations we want to do this year. Now we will show you the technical highlights of this year. In order to make a small-size soccer robot team, there are different elements needed: mechanics, electronics, control and AI. The mechanics sub-team redesigned many of the plastic parts in the robot in order to optimize them for a manufacturing process. These parts were changed to integrate multiple functions into one piece. Furthermore, the weakest components have been replaced by metal in order to increase the robot's resistance against crashes with other robots. Another focal point of the mechanics team is the design and manufacture of custom solenoids for the robot, which will have a smaller footprint than the currently used off-the-shelf components. This will also enable us to tune the characteristics of the solenoids to the electronics of the robot.
This brings us to the second half of the hardware. The electronics sub-team focused on making the electronics of the robot more robust and reliable. Thus, the top board has become a 4-layered PCB and ESD protection components have been added. Furthermore, a new DC-DC converter has been developed for a more stable power signal. The base station has also received a major overhaul this year. The base station is responsible for the communication between the central computer and the robots on the field. A custom PCB and new packet protocol were designed, which allow for wireless two-way communication with a robot at 15 kilobytes per second, which is over 10 times the speed of our previous base station. The PCB contains an SD card for logging, a screen for real-time statistics, and can be powered by a battery. The new packet protocol allows us to send a multitude of different commands and settings through the robot. It also allows the robot to send much more important feedback back to the computer, such as data from accelerometer and Kalman filters. This information leads to better robot control in our AI and faster development throughout the year. Now that we have covered the hardware and communication of the robots, we can start looking at controlling them.
The control subteam developed a new design for the control of the dribbler system. This novel approach applies robust control theory to deliver a stable controller for the dribbler. The controller employs a feedback signal from the encoder attached to the motor of the dribbler, ensuring 8 levels of speed for the dribbler, enabling new tactics to deploy in the field. For the design of the controller, it was required to have a component model of the electromechanical system of the dribbler, which additionally includes insight in the dynamics of the system. This information is used to understand the limitations of the robot's performance and gives a foundation for the improvement of the system in upcoming years. Now we've got a physically stable robot. Next we can start looking at the implementation of the gameplay, which is the responsibility of the AI subteam.
The software of a robot is big and complicated and has grown exponentially over the years. In order to innovate further, the AI subteam redesigned the system architecture such that there is a foundation for more advancements within the future of our software. The focal point of this new design is the one-directional flow of data through our codebase. This will allow the implementation of synchronization, which means we will be able to move towards more complex strategies, such as timed actions. These will make us a much more formidable opponent, as we will be able to pass to moving robots and predict where to intercept the ball. The redesign of our system architecture also gave us the opportunity to separate our interface from our AI and implement it as a web application. This has increased the maintainability of the interface and decreases its impact on the performance of the AI. Within the AI section of our codebase, many hard-coded values have been replaced by calculations. This consists mainly of computations for positioning and passing and scoring of plays. Replacing hard-coded values with computations means that we now react to our environment in a better way. And last but not least, we have laid the groundwork for a new path planning and tracking algorithm using bang-bang trajectories, and taken the first steps towards the implementation of a logging system on our brand new interface. And finally, we have implemented a new structure for the communication between plays.
The combined work of not only the technical subteams but also our PR and management have resulted in this brand new generation of robots. However, without all the hard work and dedication of our previous 4 generations, we would never gotten this far in just 5 years. Most of all, none of this would have been possible without the help of our partners, who have continued to support us throughout this challenging year. Thanks to their contributions, we continue to innovate and inspire in the field of robotics and AI.